All right, here we go. So the next section is still dealing with systems. And I know you guys are going to get mad, so I'm going to prepare for the dirty looks that can kill me. This one is on system word problems. So I know everybody always hates word problems. And this time, you still have to solve a system, but you got to write it first. So they're not going to give you a pre-written system. They're going to give you, okay.
You can still use it the same.
Absolutely. You can only use graphing, substitution, or elimination, all right? But you're going to have to write your own two-variable, two-equation system, and then you'll solve it. Today, I really want to focus on the writing of it. So I'm going to write and solve the first example with you, and then the next 4 examples, we're just going to write them. We're not going to solve them, just for time-saving purposes. I'd like to bank on the fact that you are pretty comfortable in solving a system, and you don't need to practice these ones, but we got to practice writing, all right? All right, so when you are writing a two-variable, two-equation system, here you go. I gave you a list of steps to follow. Number 1, please read the problem very, very carefully. Then, number 2 is the most important part. You have to ask yourself, what did this problem just ask me to find? Because once you know what you have to find, hint, hint, it should be 2 things. You should have to find 2 things. Once you know what those 2 things are, you can pick variables to represent whatever you want them to be. That way, when we know something in math, when we don't know something, what do? We use variables to represent them. So then you're going to use 2 variables to represent those 2 things you've been asked to find. And then you're going to use those 2 variables to write 2 equations. Not 1, 2 equations. You have to write a 2-variable, 2-equation system. So the problem should ask you to find 2 things, and then the problem should give you 1 clue to write your first equation, and a second clue to write your second equation with, all right? So let's give it a whirl. I tried to give you an extremely straightforward problem to do first, all right? So here we go. I gotta stand over here because the glare is so bad. It says Michelle is thinking of 2 numbers. The sum of these 2 numbers is 12. The difference of these same 2 numbers is -4. Write and solve a system of equations to find the 2 numbers. Okay, so we read it. Now we have to ask ourselves, what did they just ask you to find? They said find what?
12 and...
No. Somebody said it. They clearly said find the 2 numbers. That is what this problem has just asked you to do. Find the 2 numbers. So guys, tell me right now, what's a variable I could use to represent one of these numbers?
X.
X. Guys, use your favorite letter. You can use anything you want. I'm going to use X, and I'm going to let it equal the first number that I don't know. Yes?
You can always use just X and Y.
You can, and some students do. Well, Paul, you'll see in the next example, but I don't always use X and Y. What would be a good variable to represent the second number that we don't know?
Y.
Okay, so we've established what we have to find, the 2 numbers. We've picked 2 variables to represent those 2 numbers. Now we got to write our 2 equations. So guys, in math, we call this part the key. You just wrote a key establishing who your variables are and what they represent. I think that is one of the most important steps in this process. All right, so now using X and Y, let's write 2 equations. So first we're going to look for 1 clue that will help us write 1 equation. Well, guys, the first clue they told us was the sum of these 2 numbers is 12. What does it mean in math for something to have a sum of something? What are you doing with it if you're summing it? Adding. So guys, these 2 numbers, X and Y, have to have a sum. They have to add to 12. What does that look like when you write it as a mathematical equation? X and Y have to add up to 12. Go ahead. Done. X plus Y equals 12. You have just showed me that those 2 numbers have a sum of 12. Done. Now we have to look for a second clue to write a second equation. The second clue said the difference of those same two numbers is -4. Guys, when something has the difference, what operation are you showing? So now you have to show that x and y, the two numbers, subtract to -4. What does that look like when you write it as an equation?
X minus y equals -4.
Perfect. And you're done. And you did it. You just wrote a two-variable, two-equation system that we could now solve and find out who those two numbers are. Now, guys, when you're solving, you can solve it by bracket, you can solve it by substitution, or you can solve it by elimination. I'm never going to tell you you have to do a certain method. However, elimination is my favorite. So you're going to find that if I ever solve, that's probably the method that I choose to do 90% of the time. Not only that, what method is this one perfectly set up for right now anyway? You add them up, your y's cancel. So we're going to solve this one just to kind of keep the ball rolling. But in the next 4 examples, we're not going to solve. All right, so let's add them up. Use that elimination method. 2x equals 8. We divide by 2, and who do you find out x is? 4. So now what I do, I go back to my key, and I remember, oh yeah, x was my first number, and I just tend to label it over here. I put 4 as my x. That's my answer for the first number. And then we can plug them back in, but I'm not even going to write it down. If x is 4, 4 plus what other number would y have to be to equal 12?
-3.
No.
Oh, wait.
4 plus what number gets you 12? 8. Y would have to be 8. And again, we get that just from plugging back in. I just didn't write it down. So now I come over to my key, and I label that y, the second number, must have been 8, and you're done. So, I don't mean to be like, oh yeah, because guys, I'm not lying. This is a very straightforward problem. But it's just trying to show you that there are going to be 2 things that you are asked to find. There's going to be 2 clues that are given to you. 1 clue helps you write the first equation. 1 clue helps you write the second equation. All right, let's do it again. We're not going to solve the next one though. Let's just write our system. So one of the hardest parts when you're getting started is separating what information is going to get me the first equation and what information is going to get me the second equation. That's kind of where you have to learn to separate one information from the second information. All right, let's look. This one says, the Nautical Star Theater Company sold a total of 555 tickets to this year's school play, okay? Student tickets cost $4 each, and adult tickets cost $7 each. The total receipts for all the tickets sold was $2,895. That's how much money they made off selling these tickets. If that's how much money they made, how many student tickets and how many adult tickets must have been sold? Are we ready? What have you just been asked to find?
How many student tickets and how many adult?
Okay, that's the big question. How many student tickets and how many adult tickets have been sold? That's what we have been asked to find, and we do not know. So what would be a good variable to use to represent the number of student tickets that sold? Everybody can say it. S. I love it because it doesn't leave any guessing at the end when you start solving and you get S equals. It's very blatant that, oh, S is for students, so this will be the number of student tickets. So I like to use variables that go along with the problem. S does bother me because if you're not careful, S can look like a 5. So make sure you're writing very neatly and you know that it's an S and not a 5 and whatnot. All right, so we're going to let S, and this is important. It's representing how many student tickets. So it's going to represent the number of student tickets. It doesn't represent the price of a student ticket. It represents the number of those tickets that sold. So that's going to equal the number of student tickets. Got it. Well, then they asked us to find how many adult tickets must have been sold. So what would be a good variable to represent the number of adult tickets? A. Perfect. Okay. Now we got to start looking back to find out 1 clue that could help us write the first equation, and then the second clue that'll help us write the second equation. So guys, if you go back to the beginning, they're telling you that this theater company sold a total of 555 tickets. So it's got nothing to do with price. They're just telling you they sold a total of 555 tickets. Well guys, what are the only kinds of tickets they sold? Adult and student. So if S represents the number of student tickets and A represents the number of adult tickets, and they sold 555 tickets, what do S and A have to add up to? 555 tickets. So that's your first equation. S, the number of student tickets, plus A, the number of adult tickets, better equal the 555 tickets sold, because that's just talking about the number of tickets. So S plus A equals 555. Perfect. All right, the next clue, or clues really that they give you, is they tell you student tickets sell for $4 each, adult tickets sell for $7 each, and still talking about the money, they made a total off of those ticket sales, $2,895. Yes?
Whereas was 2A was.
So now you're gonna bring the money in. So guys, think of it. If this is the number of student tickets that sold, what was each one of them worth? So that's $4 per student ticket. So if they sold 10 student tickets, that's 4 times 10. That's $40 that they made. Well, we don't know how many they sold. So that's going to be $4 per S, per student ticket. So take the $4 and times it with the number of tickets, and that gets you 4S. That's the amount of money they made by selling student tickets. Do you agree? 4 times S. All right. Plus, on top of that, they've also sold adult tickets. What was each adult ticket worth?
$7.
So that's $7 per every A they sold, per A. So if $7, if they sold 10 adult tickets, that would be 7 times 10, they made $70. But I don't know how many they sold. So that's $7 times A, the number of adult tickets, so that'll be 7A. And how much should that add up to? How much money did they make off selling these tickets?
$2,895.
Done. So if you notice the difference, the first equation, guys, had nothing to do with money. It was just about the number of tickets that sold. The second equation is the one that brought the money in. So now we had $4 per student, $7 per adult, and the total amount of money they sold. And now you have written a 2-variable, 2-equation system. How'd you feel about that one? Is everybody okay?
Yeah.
All right. Now if I'm you, if I'm solving it, I'm either getting a -4 here, so my S's cancel, or I'm getting a -7 there, so my A's cancel. I love elimination, so that's how I would choose to solve it, but I am banking on the fact that you guys know how to do that, and we're not going to waste time right now. All right, let's look at number 3. Guys, if you were to look up system word problems in any math book or any online, coin problems are extremely popular system word problems, all right? And the tricky thing about the coin problems is they never write all the numbers you need in your equations in the problem. And you're going to see what I mean. There are things that they are going to assume you know that you are going to need to do a coin problem. All right, let's look at it. It says Bill has a collection of 35 coins that contains nickels and dimes. So guys, there's this guy. He's got 35 total coins. Some are nickels, some are dimes. Find the number of nickels and the number of dimes if the total face value of all the coins, if the total amount of money is $2.55. Back up. First, what have you just been asked to find?
What's the total face value of the coins?
No.
Oh, wait, no. Find the number of nickels again. Sorry.
Find the number of nickels and the number of dimes. That's your job. So you got to pick 2 variables to represent that information. So guys, if I'm asked to find the number of nickels, what would be a good variable to represent that until we know it? N. Let N equal the number of nickels that this guy has. I know he's got 35 coins, N of them are nickels. Then he's got dimes. So what would be a good variable to represent the number of dimes? D. Okay. So we got to find a clue that'll help us write the first equation. And guys, it don't matter if you wrote this one first and this one second. It doesn't matter, whichever one you want. Think about it. He's got this many nickels, and he's got this many dimes. The first clue told us, how many coins does he have?
35.
35. So guys, if he's got this many nickels, and this many dimes, and he's got 35 coins, how do we make an equation out of that? What do N and D have to add up to? Everybody, there's 30 of you in this class. What do N and D have to add up? Stop. Everybody has to get a chance. What does N and D have to add up to?
255.
No, come on, Chris, not with that. Get out of here. It's got to add to the 35 coins, right? The nickels and the dimes have to add up to the 35 coins. We haven't brought money in yet, so we can't talk about the $2.55. We're just talking about the number of coins. So we know N, the number of nickels, plus D, the number of dimes, has to add up to the 35 coins. All right. What is the only other clue they have given us about these coins? What is the only other clue? The total, which is what? What are all the coins worth? $2.55. So guys, if you have nickels and dimes, and you know how much they're all worth, $2.55, don't you have to know what each coin is worth though? So what's one nickel going to be worth? 5 cents. What's one dime going to be worth? So we're going to have to use 5 cents and 10 cents, but they're never going to write those numbers in the problem. They're going to assume that you know that you need to know the worth of each coin, and they're not going to write 5 cents and 10 cents. All right, so guys, if he's got this many nickels, and every single one of those nickels is worth 5 cents, what's 5 cents per N going to look like mathematically? 5N, except I have to use cents. So what's 5 cents? What's that decimal? 0.05. So that's going to be 0.05 per N. That is 5 cents for each nickel, right? That's how much money he'll have in nickels. Plus, on top of that, what's every single dime worth? 0.1, right? 10 cents. So that's 0.1 per dime. So that's 0.1 times D. So that'll be 0.1. I'm just going to put 0.10. So 0.10 times D. You don't need the zero though. And then that should equal, now we can talk about money. We're talking about money. How much total money was there? $2.55. And there is your two variable, two equation system. So guys, the first equation had nothing to do with money. It was all about the number of nickels and dimes and the number of coins. The second equation, though, is the one that deals with money. So now you can bring in your nickel and your dimes worth and the total amount of money. All right, now if I'm you guys, and I don't mind decimals, I just use a calculator. I would get a negative 0.05 in front of this end, so my ends cancel. Or I would get a negative 0.10 in front of this D, so my D's cancel. That's how I would choose to solve it. But if you're sitting here thinking like, Hardy, these decimals are going to be the death of me. Everybody watch this. If I move this decimal 2 spaces to the right, it becomes 5. And then you could say 5A. Plus, if I move this decimal also 2 spaces to the right, it becomes 10, and I could use 10D. And then if I move this decimal 2 spaces to the right, it becomes 255. So if you wanted to get rid of the decimals, as long as you move the decimals in equal number of spaces the same, then you can get rid of the decimals. And then you could use 5N, 10D, and 255. A lot of students, though, they always forget about the 255, and they leave that as 2.55. Do what you got to do. Yeah.
Wouldn't then the answer still
No.
be decimal?
Oh, then the answer would still be the same. You're not changing this equation when you change every single decimal.
Okay.
You change just one of them, yes, you've changed the problem, it'll change the answer. But because I've moved everything the 2 spaces to the right, it's perfectly fine. It's like timesing everything by 100. You're fine. It's just a different version of the same equation. Okay? All right. I want you guys to try number 4. Read it. Make a key. Establish what variables, who they represent, and then try to write me 2 equations using the 2 separate clues they've given you. I see. Yeah. You need your pass sign or anything?
Yeah.
the key, and I like the key.
Oh, you want to?
I want the key. I think the key is key. Yes. So, who does D represent? Who does S? You know, I guess people were yelling at me that I didn't have this plural.
I know that.
Yes. Yep. There's more than one. Perfect. Done.
Oh, sorry.
Done. Okay. So now the other numbers that you need, they didn't give you. The only other clue they tell you is that you got 96 legs going on. So now you got to start thinking about, well, how many legs does each sheep have? How many legs does each duck have to get you to that total of 96? Perfect. Perfect. Come on, Steven. Perfect. Except the pluses. Yep, they add up. Yep. Perfect. This is good. Yes, done. 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 Perfect. There you go. Perfect. Yep. Okay. So now 96 is 96 what? Legs, right? So now you have to bring in, well, how many legs does each sheep have? And how many legs does each duck have to add up to 96 total legs? Okay? Perfect. Keep going, Shemai. That's perfect. Keep going. Done. Done. There you go. Perfect. Guys, this is really good. Right? We had a farmer. He's got sheep and he's got ducks. He's got 36 total animals and 96 total legs. How many sheep and how many ducks? So S represents the number of sheep, D represents the number of ducks. So if he's got 36 animals, what do S and D have to add up to? 36. So we got sheeps plus ducks equal to 36 animals. Now again, this is one of those problems that didn't tell you all the numbers that you need. They start talking about legs and they expect you to know how many legs each sheep is going to have and how many legs each duck is going to have. So guys, if we have this many sheep, what does each sheep have as far as legs go? 4 legs. That's 4 legs per sheep. So that's 4 times S. If you had 10 sheep, you have 40 legs. All right, plus, how many legs does a duck have, though? Only 2 legs per duck, so that's 2 times D, and then that'll equal your 96 total legs that you have. Guys, that was good. I saw a lot of good answers. All right, I threw you for a loop on the last one. This one says, Tom went grocery shopping last week, and he bought 7 oranges and 5 apples for a total of $19.90. The next week, he bought 3 oranges and 6 apples, and he spent $6.05. So guys, the weird thing here is, you know how many oranges and you know how many apples he bought on both trips. So it's not like it's the number of apples and oranges that we don't know. We clearly know how many oranges and how many apples he bought. They're asking you to write a system to find the cost of each orange and the cost of each apple. Well, I don't like to use O for orange because it's going to look like a 0. So I'm going to use R to represent the cost of an orange. All right, the cost per orange. Let that be R. Whether it's 50 cents or $1 per orange, we don't know what the cost is. But that's the thing. A lot of people were writing, are you okay? I would just wait for this one. Can you wait for this one? I'll be 2 seconds. A lot of people writing the number of oranges. No, they didn't ask you to find the number of oranges. They asked you to find the cost. And then I'll use A as the cost per apple. Okay. So let's look for a clue. The first clue is what he did the first week. Guys, the first week, he went and he bought 7 oranges and 5 apples for a total of $19.19. We have to turn that into an equation. So guys, he bought 7 oranges, and it's R per orange. It's R. That is the cost per orange. So if it was $1 per orange, and he bought 7 of them, how would you find out how much money he spent? 7 times 1, the $1. So if he bought 7 oranges, and that's the price per orange, he's going to spend how much money on oranges? 7 times, what's the cost? Oh boy.
R.
Are you the only person that knows that? No? If that's the cost, maybe I spoke Chinese there. Hold on, let's go back. This is the cost per orange. This is the cost per apple. He bought 7 oranges at this much per orange. So if that was $1, if the cost was $1 and he bought 7 oranges, how much money did he spend? 7 times 1, 7 times the cost. So if the cost is R per orange and he bought 7 of them, how much money did he spend? 7 times R, 7 times the cost, 7R. Plus, he bought 5 apples. The cost of 1 apple is A. So that's 5 times what? A. Beautiful. 5 times the cost of an apple. And that has to add up to how much total money did he spend? $19.90. The next week, here's clue 2. He bought 3 oranges and 6 apples for a total of $16.05. So guys, if he bought 3 orange and this is the cost per orange, how much money did he spend? 3 times R. 3 times the cost. Plus, if he bought 6 apples and this is the cost per apple, how much money did he spend? 6 times the cost A. And then this time he spent how much money? $16.05. So they kind of flipped this one. Usually they tell you the cost and you have to find out how many oranges or apples you spent. This time they told you the number of apples and oranges, but they didn't tell you the cost. But it's still multiplication. You're always multiplying the cost with the number, okay? All right, so what I'm gonna do now is I'm giving you an exit ticket. It's just one more problem. You don't have to solve it, you just write me this system. And then you're gonna turn it over and you're gonna hand it in before you leave. And then Jake, you gotta get a pass.
Yeah, I never got mine.
So write your 2 variables. And then get me 2 equations.
Thank you.
You're welcome.